Welcome back. In the previous video, we turned broader and more philosophical. In this video, we turn diametrically opposite. We look at the weeds of treasury trading, arbitrage, and synthetic security. It's way more algebra intensive, but it's useful to understand, if not all the details, then at least the concepts. There are many secondary financial markets that Wall Street creates in exactly such ways. This subject and video is thus a little bit more involved and perhaps better suited for those with more interest in finance. For everyone else, it's more important to understand the concepts than the details. Fixed income is at the same time not only the most theoretical, but also the most applied practical material in corporate finance. It's also the most notation and algebra heavy, which is never a lot of fun. So this video may not be for the faint of heart. There's two kinds of interest rates. There is the spot interest rate, which is the currently prevailing interest for an investment starting today, right now. And then there is the forward interest rate, which is an interest rate that will begin with a cash investment in the future. So it's of course the opposite of a spot rate. Here's an example: the interest rate on a 5-year bond to be issued in 2040, coming due in 2045. Yes, such instruments exist and they're easily purchasable. Like all other interest rates, spot and forward rates are usually quoted in annualized terms. Not only spot, but also forward rates enjoy very lively active trading, both fundamental, where there is a party that knows that they will need to issue in the future in 2040, and parties that just want to speculate where interest rates will be at that point. Annualized interest rates are a little lower than equivalent average interest rates because they take into account the interest on the interest. So here's an example. If we have an annual interest rate of 12%, the average monthly interest rate is 1%, but the annualized interest rate is 0.95% because you compound 1.0095 12 times and you get 12%. Here's the first question. What is the annual spot rate on a 1-year treasury bill today, on a 2-year treasury bill today, on a 30-year T-bond today? For this, you have to go to the internet and just find out.
Please pause this video now, answer the question on a piece of paper, and then continue.
I find my source at the Treasury website. Here is the URL. You can easily look it up for yourself. What does the yield curve today imply about future interest rates? And can you lock in the future interest rate today? So I need more notation. I'm going to name the annualized interest rate over 15 years to be R subscript 15, and I'm going to put a little overline over the 15. And this is notation I had to invent because there is no standard notation for annualized interest rates over longer horizon. So my notation. The R15 overline annualized yield contrasts with our notation for the 15-year holding rate of return, which is R sub 0,15. And there's a simple relation between all of those interest rates. So the annualized interest rate over 15 years is the same as if I take all the 1-year interest rates and compound them, or if I compound the 1 plus R15 bar. Now, let's work through an example. Let's presume that the 5-year holding rate of return, R05, is 27.63%. What is the annualized interest rate R5? Little overbar.
Please pause this video now, answer the question on a piece of paper, and then continue.
It's 5% because 1 plus R05 to the power of 1/5 is 1 plus 5%. Okay, no big surprise. I chose it to be this way. 3 years, same as before. This is just a notation summary, but this is the one we're going to use in examples in the following pages. So I've got the 1-year rate, I've got the 2-year rate, the 2-year annualized rate, and the 2 individual 1-year rates. And I've got the 3-year holding rate of return, the 3-year annualized rate of return, and the 3 individual 1-year rates of return. Standard convention now is year 0. The interest rate from year 1 to year 2 is going to be called the 1-year forward rate in 1 year. The interest rate from year 2 to year 3 is the 1-year forward rate in 2 years. So that's R2, 3. In a world of certainty, the forward rate will be the future spot rate. We already know it today. An annualized rate is more like an average. A holding rate of return is more like a sum. So let's do it. A 1-year bond has a rate of return of 5%. When it will come due, you will be able to purchase another 1-year bond that will have an annual rate of return of 10%. And when that bond will come due, you will be able to purchase yet another 1-year bond that will have an annual rate of return of 15%. And first, write down the 3 rates in our notation, please.
Please pause this video now, answer the question on a piece of paper, and then continue.
There is the notation, R01, R12, and R23. Now, I want you to think, without a calculator, just intuitively, what you think the 3 total holding rates of returns are going to be. That is from 0 to 1, from 0 to 2, and from 0 to 3. Just approximately.
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, it's got to be around 5%. Then, because I make 5% and another 10%, if I ignore the interest on the interest, it's going to be 15%. And finally, it's going to be 30%. So the 3-year holding rate of return, R03, got to be around 30%. What are the 3 annualized rates of returns? That is, from 0 to 1, from 0 to 2, and from 0 to 3. This one's got to be 5%, well, that we know. Then it should be about 7.5%. If I make 5% the first year and 10% the second year, my annualized almost average rate of return's got to be about 7.5%. And then finally, over 3 years, the average got to be around 10%. So here's what I want you to do now. You know the approximate values already, and I've written them in here for you. What I want you to do is fill in the exact rates here.
Please pause this video now, answer the question on a piece of paper, and then continue.
Here is the answer. So spot and forward rates were, of course, given 5, 10, and 15%. The holding rate of return is not going to be 5, 15, and 30, but it's 5, 15.5, and 32.8%. And the annualized interest rate is going to be 5%, 7.47%, and 9.92%. I've put the calculations for you right there at the bottom of the slide. So my advice is assess the magnitudes first. Use over the envelope intuition for the magnitudes. Because the annualized yield is an average of spot and forward rates, the forward rates rise or decline faster than the yield curve. So if I have a 5% and then a 6% annualized rate, where the annualized rate over 2 years is R2 overline over bar, then I know that my future 1 year rate has got to be greater than 6%. In fact, it's got to be around 7% so that it averages to about 6%. The following contain all the same information. If I give you a full set of annualized rates of return, which is the yield curve, it's the same information as if I gave you a full set of spot and forward rates, or a full set of holding rates. Each can be translated into the others. So, yield curve summary. The yield curve is the term structure of interest rates with a curve plotting the annualized interest rate on the y-axis against the time of the payment on the x-axis. Although I've pretended that yield curves are based on true zero coupon interest rates, those are called treasury strips, usually they come from coupon bonds. It's not that important. Now, it turns out, knowing all this, I can lock in the forward rate. The forward rate is something like R subscript 2, 3. So if I give you the current yield curve, you can extract, if you look backwards, the full set of holding rates and spot and forward rates. So in the real world, you typically have the thing on the far right, and you want the spot and the forward rates. You now have the annualized interest rates. You can extract the forward rates. And if you have those in the book, it's nicely explained how you can use this to create a zero investment at the moment that commits you to going long $1 million treasuries in 3 years, lasting until 4 years, or any other time period you would like. In the real world, there's another complication. You can indeed lock in the interest rate as you wish today, but when the time comes, the future interest rates can be different from today's forward rates. This is because there's uncertainty, and we haven't covered uncertainty yet. So if you're dealing with this kind of situation, now you would have to distinguish between a forward rate that you're locking in right now. So now you have 3 subscripts against another rate, another forward rate that you may lock in a year, and the actual rate that will actually occur. So it's a notation nightmare, just yikes. But if you're trading in bonds, that's absolutely essential. Final topic. There's something called a continuously compounded interest rate. That assumes that interest is paid not once per year, but continuously. So let me give you the flavor of this. So consider 10% compounded once at the end of the year, or 5% compounded twice, that is every 6 months. Well, you do that, 1.05 times 1.05 is 10.25% plus 1. Or you can compound 1% 10 times. That gives you 10.46%. Or 0.1% 100 times. That would give you 10.5%. If you do this smaller and smaller and smaller and smaller, that is, you continuously compound, you come out with a rate of return of 10.5171%. That is from the formula e to the power of 10% minus 1. You can turn that around. So you can figure out what is the equivalent simple interest rate. That is the log of 1.105171. The advantage is that whereas the simple interest rate is asymmetric, you can't lose more than 100%, the continuously compounded interest rate is symmetric. It will go from minus infinity to plus infinity. It's also used heavily in option pricing. It's also additive. At this point, you don't actually have to worry about interest on interest anymore. You can simply add up continuously compounded interest rates. However, in this beginnings course, we're not going to do more with it. You now understand how spot and forward rates work. So if you ever want to lock in a future interest rates, you understand how it's done, how JP Morgan or Goldman Sachs would do it for you. That's it for this video, for Chapter 5 and for term structures. Chapter 5 already. Wow. It's also pretty much it for most of the pure interest-related parts of this class. It was quick, but perhaps not entirely painless. In the next chapter, we'll get to the more exciting parts, the parts where you may not get what you think you're supposed to get. Of course, this may not be the kind of excitement that you're after, especially if you're not getting paid. See you soon. Bis bald.
I'm running out of jokes.
You don't have one with the phrase forward?
Only a bad one.
Let's hear it.
Okay. Donald Trump is walking out of the White House and heading towards his limo when a possible assassin steps forward and aims a gun. A Secret Service agent new on the job shouts, "Mickey Mouse!" This startles the would-be assassin and he's captured. Later, the Secret Service agent's supervisor takes him aside and asks, "What in the hell made you shout Mickey Mouse?" Blushing, the agent replies, "I got nervous. I meant to shout, 'Donald, duck!'"